Hello guys. I'm really sorry about this poor internet connection. Please, can you hear me? Hello?
Yeah, we can hear you.
All right, all right, all right. Can you see my screen? Hello, can you see my screen?
How's your family? How's your family doing?
Can you see my screen?
Yes, sir, we can see your screen.
All right, okay, let's continue. I hope this stuff doesn't kick me out again, hopefully. Okay, yeah. So we're talking about solidity value types, and these are the list of value types we have: the signed integer, the unsigned integer, the boolean, the address, and the enums, and the fixed size or fixed size bytes. Like I was saying something earlier, that if you look at the value types, they are all
Yeah,
related to numbers. Can you hear me?
I'm in a class now.
Can you hear me? Someone is saying something in the background. Hello, if you can hear me, can you say something? So I'm sure.
Yes, sir, we can hear you.
All right. So I said that all the value types in Solidity are related to numbers. We will look at that. But if you have a question about that, or you want to say something about it, you can drop it in the chat. I'll see it. So all the value types in Solidity has something to do with numbers and all of that. So let's move to the next slide. Now, the next stuff we have here is the reference type. So reference type differs from value type in that they do not store values directly on their own. Pay
So
attention.
what by reference?
Pay attention. Value types stores their value in their own memory. They hold in their own memory. But reference types do not store like value directly on their own. Instead, they reference the location to where the actual value is stored. I don't know if that makes sense. So reference type, if you're using reference type, you reference the location where the data is being stored. So you do not directly copy it to where you're using it. You only reference to the location where it's being stored. That's why they're called reference types. So example of reference types in Solidity are array. We have both fixed size array and dynamic sized array, and the bytes array. So, in value types, we mention bytes, and we say bytes, this byte, the fixed size bytes are value type. But here, we are still mentioning bytes again, but these are dynamic bytes. They are not fixed. So I'm going to show you this. Let me go to my remix. Let me write out all the value types.
Natural.
So for
Wow.
value types, we have the int. Let me say this is num. We have the uint. Let me say this is num1. We have address. Let me call this owner. What again? Int, uint, address. We have enum. Let me call these what do I call this? Status. Yeah. We say the first status, we can call it pending. And we have completed. Yeah. So this is enum. Which other value type do we have? 1, 2, 3, 4. Let me check this guy again. So we have Boolean. Okay, yeah. We have Boolean, which is bool is started. And we have bytes. We can call this byte 1 and call this mem. So, and you call this bytes 32, we call this mem 2. Now, all this stuff I just listed, all this stuff you're seeing on my screen, these are all value types, and they are all related to numbers. Now, integer is a number. Unsigned integer is a number. Address. How many of you have seen an Ethereum address? Let me get one for you. This is an address. Now, let me paste this here so you look at it very well. This is an address. Is this a number or it's not a number? Please make use of the chat section. Let me be sure you're following. I like interactive session. I don't like talking. Is this a number or this is a number, true or false? If you agree with me, make use of the chat section. If you say it's a number, say true. If you don't agree it's a number, say false. Hello, guys, come on. It's a mixed number and letters. Okay, number. Okay, S is a number. Lancer says it's mixed number and letters. Who else? True is correct. Temi or Joy is hexadecimal number. So this is a hexadecimal number and it can be converted to a decimal number. Now that's it. For Boolean is either true or false. Is this a number or it's not a number? Can this be interpreted as a number or not? If it can be interpreted as a number, say yes. If it cannot be interpreted as a number, say no. Okay, correct. Because true is 1, false is 0. It can be interpreted as a number. Now, similarly, bytes, these are also hexadecimal number. So let me quickly show you something. Let me open up my terminal and show you something. Let's use this guy instead. So it will show very well. Yeah. So go. So let's do something like chisel. All right. So now I want to do something. Type of bytes 1 dot max. Okay, let's see. Type of bytes 1. Oh, it's not bringing anything. Okay, so bytes are hexadecimal number. I wanted to, okay, let me check type of uint 256 dot max. All right, okay. So this is what I was trying to get for the bytes, but it's not giving me a value. So bytes are hexadecimal numbers as well. And hexadecimal numbers are numbers. They can be converted to decimal numbers. That is why I said all value types are related to numbers. They might not be numbers in the literal sense, like something like this now is not a number, but it can be related to numbers. Now, enums, this enum, the members of these enums are referenced as numbers. This is 0, this is 1, and the third one is 2. So that is why I said all value types are related to numbers. Now let's look at reference types. Reference types, like I said, you cannot copy them. You can only reference them. For instance, let's look at something like mapping. Let's say a mapping of address to uint 256, and we call this user balance, right? Now, if I want to make use of this mapping inside a function, let's say something like this function, get user balance, and I do something like this, external this, and I want to make use of this mapping, all I'll do now, I'll just say user balance into the person calling this this function, msg.sender, and I'll do like plus equal to, let's say 10. Now, you see that this plus equal to 10 I did, this stuff now, it's changing the value of this user in this mapping. It's referencing this user in this mapping variable. It's not copying its own memory. That is why they call them reference type. So what I'm doing now is actually modifying the state of this user in this mapping. Unlike when I was using num1 here, for instance, let me use this num1. If I wanted to use num1 here, I can say uint num new num is equal to num1. Here now, I am creating a new variable and I'm holding it in num1. If I do something like new num plus 5, you notice that the only thing I'm changing is new num. Num1 remains the same. Is that making, if it's making sense, type yes in the comment section, in the chat box. If it's not making sense, type no, so I know what I'm doing. Hello, guys. Is it making sense? Awesome, awesome, awesome. Now, so this is how value type and reference type works in Solidity. So I'm trying as much as I can not to go into complex stuff so you don't get confused. So let's continue. All right. So someone saying something? All right. So let me just write out the reference type so you see how they look like. So I've written mapping here. Let me remove this function. I've written mapping here. Let me write an array. So in Solidity, before you write an array, you have to tell Solidity the type that the array will contain. For instance, if I want my array to hold only numbers, I'll say uint array, and I'll call it number array. So this array can never hold a string. And if I want an array of string, I'll say string array. I can call this fruits. So I'll call this fruits. So this is a string array. This array can only hold strings. It can never hold a number. If you put a number inside, your Solidity compiler is going to throw an error. Now, this is a dynamic size array. You see that with this kind of array now, the number of elements it contains varies. It can be as much as possible. But now let me create a fixed size array. So let me say uint, and I do something like this, and I say 5, and I call this 5 numbers. Now, this array cannot hold more than 5 elements inside. This is a fixed size array. It can only hold 5 different numbers in it. This is a fixed size array. That's why if you see here, I wrote array, fixed size, and dynamic size. So I've shown you the dynamic size array, and I've shown you a fixed size array. You can also do this for string as well. You can say string, and you say 10.
What do you call it?
I do something like 10,
Okay.
10 names. So this can only hold 10 different names. So please, if you're talking, can you mute your mic, please?
Yeah.
All right. So this can only hold 10 different strings. So with this 10 inside, it's telling the Solidity compiler that this can only hold 10 different strings. It can't hold more than 10 different strings because the type is string and you give it a size of 10. So it cannot hold more than 10 elements and all of that. So let's move over. Byte array. So this byte array is just something like this. Let's say bytes, and I call it my bytes. So notice the difference. This one is just bytes. It doesn't have a number in front of it. So this is a reference type. But this one is byte 1, byte 32. This has a number. So this is a value type. This is an array. This is a dynamic byte array. So that is why it's a reference type. Let's move on to the next stuff. We have string. String is a reference type. Struct is a reference type, and mapping. Now, string, we have used string here. Just string, anything that has to do with letters. String, my name, and that. Then for struct, now struct is what makes Solidity very sweet. Now, guys, listen and listen very well. If you want to be a very proficient Solidity developer, there are specific data types you need to know how to use very well and how to manipulate. I'm going to list them. Struct is one of them. So let's say struct person, right? And we have person. What are the properties of a person? String name. Person will have a name. A person will have age. So we say uint age. A person will have date of birth. Date of birth can obviously be stored with string. So you say string DOB and all of that. So this struct gives you the ability to create your own user-defined type in Solidity. And it helps you group things together. For instance, let's say when we'll be writing a to-do smart contract, and if we want to write our to-do smart contract, how do we group to-do items together? You can just create a struct here called struct to-do. And in your to-do, what are the things a to-do will contain? String, the title of your task. What else? The description, string, description. What else? Is your task done or not? Bool. So this would be bool. You call it is completed. So this can be true or false if that task is completed or not. So this is what struct helps you to do. It helps you to create your own user-defined type in Solidity, and it is a reference type. It is not a value type. So I was saying something that if you want to be very proficient in Solidity, there are certain data types you need to understand how they work and know how to manipulate them very well. Number one is mapping. You need to know how to use mapping very well if you want to be a badass Solidity developer. Number two is array. You really need to know how to work with arrays. Number three is struct. You have to really know when to use struct and how to use struct. You don't really need to make use of enum all the time, but enum comes in handy too in Solidity. Now, every other thing, this is just number, uint, this is just number. Address is it just holds an address for you. Bool just holds true or false for you. But you see these guys mapping array struct and this guy. Another one you need to know how to use very well is this bytes. You need to know how to use bytes very, very well, because it's mostly used for what is it called? For when you want to hash stuff in Solidity. This is where bytes comes in, byte and fixed byte arrays and all of that. They come in very handy. So if you know how to use these guys, these 5 data types in Solidity, trust me, there is no complex Solidity smart contract you won't be able to write. Mapping can go all the way to 3D mapping. You can have something like this, mapping into an address pointing to another mapping into a uint pointing to maybe a uint and all of that. You can call this, someone is trying to join, and you can call this anything you want. Now, these are complex data structures in Solidity, and when you know how to manipulate them, you will know how to write any kind of smart contract. All right, that being said, let's move over to, well, we have taken a lot of time on data types. All right, so let's move over to functions in Solidity. Are you guys following? If you're following, please type yes. I want to see more yes. We have up to like 10 persons here. Yes, 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 3. More persons, please. Yes, 4. More persons. Yeah. Yes. Yes, yes. Okay, good. Yes. All right, let's continue. So let's move over to functions in Solidity. If you're a programmer before now, you already know what a function is. So a function is a group of reusable code which can be called anywhere in your program. This eliminates the need of writing the same code again and again. So like, you know, the dry principle, don't repeat yourself, keep it dry. So it helps programmers to write modular code. Function allow a programmer to divide a big program into a number of small manageable functions. Yeah, so this is just what functions do. Like, instead of you writing so many lines of code, I have a bad principle in writing code. If my code is exceeding like, it's getting to like 15, 20 lines, even 10 lines or more, it's becoming bloated. Trust me, it's becoming bloated. I like keeping it simple. In programming, we call it single responsibility. Separate everything in function and use your functions inside the main function that you want to perform the main function that will be called externally, while every other thing are helper functions inside your code base. So once you look at your code, everything is simple, like 3 lines, everything is short and sweet to read. Unlike having a long code, long function with so many stuff inside, doesn't make sense. Yeah, and Solidity have what they call stack to deep. It will help you minimize the number of local variables you declare inside your function. All right, so about that, let's move over to the next slide. So types of functions in Solidity. We have view functions, we have pure functions, we have spatial functions, we have fallback functions. Now, a view function is a function that is being used to return something, like it's just a read-only function, basically used to read something from the blockchain state. Now, we are going to talk about blockchain state while we start writing smart contract. So let me quickly show you an example of what a view function does. So I'm going to clear, should I clear this stuff? Okay, there is a recording, so you guys can always watch this. So let me quickly clear all of this. So I show you what a view function looks like. Like I said, this is more practical than theory. Yep. So let's clear this guy. All right. So now I want to declare a variable called, let me declare a string variable, and I'll call it name, and I'll assign it my name as Sweeney, right? Now let me create a function. I'll call this function view name. And this is going to be an external view function. Now, view function always returns something. Pay attention. View functions always return something. View functions always return something. So external view returns, but not all the time though, because there are some private view functions that you're just using as a helper function, but they don't return anything. But anytime you want a function to return something, like you want a view function to be seen outside, you always put the return keyword. So this is going to return a string. So you have to specify that it returns a string. And now, since string is a reference type, pay attention, string is a reference type, you have to specify the location of what you want to return. A lot of times you use memory. The reason why you use memory, I'm going to explain storage and memory in one of the slides here. The reason why you use memory is because this is only being used in this function execution. Once this function finishes executing, it is deleted, it is cleared from the memory. So external view returns string. So all I just need to do, I'll say return name. Now, watch guys. If I deploy this smart contract, let me deploy it. I've deployed it. If I open this smart contract and I click view name, can you see my name here, Kaswini? Can you see it? If you can, type yes, please. Hello, are you guys following? All right. So this is an example of a view function, right? Now let's move over. Now we talked about pure functions. Pure functions declare that no state. This is big English. Pure functions are functions that neither change the state of the blockchain nor return anything from the blockchain. You see, view functions return something, they return the blockchain state. Pure function, they don't return anything, as in they don't return the blockchain state, neither do they modify the blockchain state. They are basically used for mathematical computations. Let me show you an example of a pure function here. So let's say I want to create a function. Let's call this function add. And this function is going to take in two parameters, because any function that is adding something definitely needs to add two things. So you need to take in uint A, uint A and uint B. And this is external. So for teaching sake, I'm going to make use of view so that you guys will see what will happen. View returns uint. Now you see that I'm returning a value type, so I don't need to specify a memory because this is a value type. Now I want to return A plus B. Watch what solid. See solid. Are you guys seeing the red underline? If I hover on it, it will tell you function state mutability can be restricted to few. The reason why it's telling you this is because this function is not returning anything from the state. Now, any variable you set, any variable you declare outside a function is a state variable, and it is anything you store to that variable is storing on the blockchain directly. That is why we call them state variable. Anything that is returning any variable that is declared in the state is a view function. So it's reading the state. But this one is not reading the state. It's only returning two arguments that is being passed to the function. So this is supposed to be a pure function. So once we change this to pure now, you see that Solidity is no longer complaining. Does it make sense, guys? Please make use of the chat section so I know I get motivated to talk more. Is it making sense? Hello, guys. I'm getting just, okay. All right. So this is pure function. Now let's move on to the next type of function. We have the special function. I'm going to talk about just the getter function. There is a function called a receive function and a payable function. Just to keep things simple and less complicated because we don't have much time, I'm going to talk about the getter function. The receive function is basically used to receive Ether. Like Ether is the native currency of the Ethereum blockchain. So the receive function, once you have it inside your smart contract, when someone sends Ether to your contract, that Ether will enter your contract. It will go to your, like you want to send money from one address to another address. Now, for you to send Ether to a smart contract, that smart contract needs to have a receive function. Then the payable function is used if you want a function to receive Ether. That's where you make use of payable. So the getter function, now pay attention, guys. Let me show you this stuff. Let me show you what a getter function looks like. When you declare, let me remove this view name here. When you declare a state variable and you add public, and you add public to it, automatically it becomes a getter function. You don't need to write a function to return this state again. This is what you refer to as a getter function. So if I delete this smart contract and deploy it again, if I click here and scroll down, you see now we have name, which is this guy. And the reason why we have this name here is because of this public we added to it. If I click on it, you see Kaswini, because it's a getter function. It's returning whatever value is being stored to it. Now let's try something else. Let me delete this contract and remove the public from here. If I remove this public and deploy this contract again, if I click here, you see that the name is no longer there because there's no public to it. Does it make sense, guys? Hope I'm not too fast. Please, does it make sense? Hello, guys. Are you guys listening? Hope I'm not too fast. If I'm too fast, let me know. Am I too fast? Hello, am I too fast? All right, all right, all right. Okay, let's proceed. So now, this is about the special functions. Now, let's look at the fallback function. I remember Sarah said something about a fallback function yesterday. Okay, that was when you guys were taking the quiz. A fallback function is an external function without a name or argument or return value. A fallback function are executed when a function identifier doesn't match any of the available function in the smart contract. So what this means is, if I try to call, let's say I wrote a couple of functions in a smart contract, and I used a smart contract address and I tried to call a function in that smart contract that doesn't exist. Once I call that function and that function doesn't exist in a smart contract, it will trigger the fallback function. So that is one of the use cases of a fallback function. But we'll explore more on that as we keep building, so we don't take too much time. These are like topics. These are supposed to be topics on their own. Things like fallback functions are supposed to be topics on their own, so we don't waste much time on it, right? So let's continue. So the next thing we have here is visibility modifiers. This is very important in Solidity, very, very important in Solidity. So these are function visibility modifiers. We have public functions, external functions, internal functions, and private functions. So let me clear this guy again. So I'm going to create a couple of functions. I'm going to say function public. I'm just going to give it has public, and this is going to be a public function. And I'm going to declare in that function, I'll say function, I'll call this cast external. So this is an external function. I'm going to create another function. I'll call this CAS internal. And this is an internal function. And I'll call this CAS private. So this is a private function. Now, you see all these functions, their level of visibility determines the amount of gas they consume. The function with the lowest visibility consumes the less gas. Listen, private functions are functions that can only be called inside the smart contract that they are declared or that they were declared. Pay attention. Private function is just like other programming language or other programming languages. When you declare a private function, it can only be called inside the class where it is being declared. That is what private function does. And private function consumes the least amount of gas. You know, when you're interacting with a smart contract, you pay for gas fee. Private function consumes the least amount of gas. If you write a smart contract and you write private function in that smart contract, if you inherit the smart contract, you will not inherit the private functions. For instance, let me show you. So I'm going to create another contract here. I'll call it the inherited. And this contract is going to have a function. It's going to be my private. It's going to be my private, and I'm going to call it private function and this. So, sorry, I made a mistake in the spelling. Function, yeah. So this function now, what I want this function to do, I'm going to give it a uint A, comma, a uint B, and I want it to return A plus B. Now, return A plus B. Pay attention, guys. Private, yeah. Returns. I didn't put the returns keyword. That's why it's giving me that error. Uint. So now this is going to be a private Q function because, yeah, a private Q function. Now we are good. So what I'm teaching you inheritance, and I'm also teaching you visibility modifier. So pay close attention. Now, I want this teaching contract, this contract teaching to inherit this other contract. So to inherit it, I'm going to do is the inherited. Pay attention, guys. This is getting interesting. Now, I've inherited this contract now. Now, look, let me deploy this teaching contract. I want you guys to pay close attention. I'll delete it. Now, I'll deploy the teaching contract. If you look here, you will see that I can only see CAS external and CAS public, because this external and this public can be called outside the smart contract, but they can be called outside the smart contract. Now, let's try out something. Let's try out something. Let me delete this guy. Now, inside this CAS, please, sir, what does the private pure function return? It returns a uint. It returns an unsigned integer. Look at it here. Yeah, so look at what it's returning. A plus B. is an unsigned integer. So now, guys, pay attention. Now, I want to use this function. Remember, I inherited the inherited smart contract. I want to use this function inside here. Now, let me do something like my private here. And I'm going to pass 4,6. Let's see. Now, guys, can you see that this stuff is showing red? Can you guys see it? If you can see it, just type yes. Now, it's showing red. The reason why it's showing this red is because this teaching contract cannot see this function because this is private. This private function can only be used inside this smart contract. Now, watch, pay attention. Let me change this to internal. If I change this to internal, can you see that it's no longer throwing an error? So all I just need to do is I'll make this a view function and I'll say returns uint. Sorry, since this is not reading from the state, it's supposed to be a pure function. And this returns uint. So I'm going to return this here. Now, pay attention, guys. Please follow me closely. You see that now this stuff is not complaining here again. But if I change this to private, once I change this to private, you see it's complaining. Can you guys see that? Are you guys seeing it? Is it making sense? Please motivate me. Type, let me know. If it's not making sense, let me know. Let me explain again. Hello, guys. Hello, people. All right. So what I'm saying in essence is, when you inherit a smart contract, you're supposed to inherit everything, all the function in that smart contract. But private functions, private functions can only be used inside the smart contract where it was declared. You cannot inherit it because this contract now is not seeing it because of this private keyword. But if I change this private keyword to internal, you see that that error is no longer showing here because internal functions can be called inside the function, inside the contract where it's declared, and also inside the contract that inherits the parent contract. So one thing about function visibility modifiers is the more you write smart contract, you get used to it. Now, the other two types of visibility modifiers are the external and the public. The external functions can only be called outside a smart contract. You can't call it inside a smart contract. You can only call it outside a smart contract. Why public functions can be called both outside a contract and inside a smart contract. So, and in all these visibility modifiers, the one that consumes the highest gas is public because it has the highest level of visibility. You can call it outside, you can call it inside. External function, you can only call it outside. Internal functions, you can only call it inside the smart contract that contains the function and also in a smart contract that inherits the parent contract. While private functions can only be used inside the smart contract where it's been declared. See this just the same way you understand functions inside classes in your various programming languages. When you declare a class, you have your private functions, your public functions, and all of that. That is the same way these visibility modifiers work in Solidity. All right. Remember, we still need to write smart contract today. Someone is coming in. All right, so let's go. All right, so the next stuff we have here is storage and memory. Let's see how many slides we have left. We have, okay, we have storage and memory. So what I'm going to, how I'm going to explain this, I'll use your laptop to explain this. All right, let's continue. So I know all of you here are very familiar with computers, your laptops, and all of that. Now, the storage in Solidity is the same thing as your hard drive. Your hard drive, whether you're using HDD or SSD, that is what storage is synonymous to in your computer. Why the memory in Solidity is synonymous to your RAM? Is synonymous to your RAM. Now, when you copy something in your computer, that thing you copy is temporarily stored in your RAM, pending when you paste it. The moment you paste that thing, it leaves your RAM and is now kept in your hard drive. Your hard drive is a permanent storage, while your RAM is a temporary storage that is just holding something pending when an execution occurs. Now, bring that back to Solidity. Whenever you make use of storage in Solidity, you're telling Solidity that this thing, I want it to be permanently stored on the blockchain storage. And anytime you make use of memory in Solidity, these are things that are, memory are mostly used inside functions or in when you want to use a function argument. That's where memory is mostly used. And it's only available in that function execution. Once that function is completely executed, that memory is dropped. The same way your RAM functions in your laptop. Once you copy something, it's in your memory. Once you paste it, it leaves your memory and it goes to storage. So that is what this whole storage and memory stuff does in Solidity. You will see more of it when we start writing smart contracts. So let's move on to the next guy. Which slide is this? Okay. So the next guy is a smart contract structure. So I'm going to show you the structure of a smart contract. Whenever you're writing a smart contract, you need to pay attention to this structure. Now, for instance, let's, when we talk about those of us that write HTML, there's what we call HTML document structure, where you declare your HTML tag, you have your head section, you have your body. Inside your head section, you have your title, your links to external CSS. Then inside the body at the bottom, you have where you link to your JavaScript file and all of that. That is your HTML document structure. Now, your smart contract structure simply refers to the structure, like what a smart contract looks like, even if it doesn't have a lot of stuff, what a smart contract should just look like. Can you guys still hear me, please? Hello, can you hear me? Let me be sure. All right. So now I'm going to declare the first thing you declare in your smart contract is the license identifier. So it's mostly XPDX dash license dash identifier. I mostly use MIT. So this license identifier is synonymous to your doc type in HTML. When you do your doc type, you do all the stuff. So license identifier basically tells you're just declaring the license, the supported license for this smart contract. And just like your doc type, you just add it in your what's it called, your HTML. And a lot of times, most of you don't know what they do. Yeah, it tells your HTML or your browser the type of encoding it should use for your web page and all of that. So for most of us that started writing HTML from HTML 1.0 to HTML 2.0 strict to HTML5, we understand this doc type and all of that. So this is like telling your like declaring the kind of license to use in this Solidity. Sometimes you can use things like you can use something like unlicensed. Yeah, you can use this too if you don't want to put any license to it, but I like using MIT. Now, the next thing you do is you declare your pragma statement. So this pragma statement is like telling Solidity the compiler version it should use. So you do something like this, 0.8.4. Sorry, 0.8.4. Sometimes you do 0.8.0. So what this thing is saying is this caret sign here is telling it that compiler version from 0.8.0 and above. Sometimes you can use something like equal to 0.8.0. This is telling Solidity that it must use 0.8.0 as a compiler version. So if you see it's trying to download the compiler now for this, but let me just keep it at this guy. So it works. The compiler is trying to compile this. This is one thing with Remix, is it will try to download the compiler for this guy. So after this is done, the next thing you need to do is declare your contract. Now, this contract keyword is telling Solidity that this is where smart contracts start. So once you call contract, a lot of times we like using the convention of naming our smart contract to be synonymous to the name of our file. As you can see here, the name is teaching. So I want my smart contract name to also be teaching. So even if you don't call it teaching, it will still work. I can call it, who is the popular guy in this? Lancer. I can call it Lancer and it will still work. But when you start dealing with complex codes, complex code base, it becomes very confusing to handle. So it's a lot of times it's advisable to make sure that the name of your contract is the same thing as the name of your file. So I'm going to call it teaching. Now we have gotten our first basic structure. Now the next thing we need to do is, okay, declare a couple of state variables. That's if we need it. So I want to declare a variable called owner. So, and this will hold the owner of this the address of the owner of this smart contract. Then I'm going to create a constructor. A constructor function is a function that runs once. And this constructor function in Solidity runs when you're deploying your smart contract. You declare your constructor, you declare a couple of functions. Let's say I call this function change owner. And I'll just say this is an external function. Now we have gotten our smart contract structure. So you can start building upon this. Your smart contract structure can as well just be this. Let me show you. The smart contract structure can as well just be this. So smart contract structure just refers to the basic structure of a smart contract. You can define it to be whatever you want. You can just keep it like this. Then you can start building and all of that. So this is just what a smart contract structure looks like. Then the more you think about what you're building, okay, if I say I want user to be able to withdraw money from this smart contract, I'll now say, okay, let's add a function called withdraw and all of that. So these are just, you're just putting empty functions that you fill up later. So this is smart contract structure. Does it make sense, guys? Is it making sense? Why is it only Lancer that is responding? Is it getting worse? Is it getting confusing? Hello, guys. Let me know, please. Yeah, it's expected to get confusing. If this is the first time you're jumping on Solidity, yeah, it's expected. Okay, let's proceed. So we talked about state variables, constructor, functions, local variables, modifiers. So local variables are just variables inside a function. I can say uint number, I say equals to 10. This is a local variable because it's declared inside a function. And modifiers, I can say modifier, I call this only owner. And I do something like this. So this is a modifier. I just say require. I don't want you guys to get confused. So let's leave it at that. When we start writing smart contract, I'll be explaining most of these things. All right. Yeah, there's a recording. Can there be a recording of the class so that we can go through it again? Yeah, there's a recording. Yeah, there is. Okay, so let's continue. Let's go back to this guy. So smart contract API. Now, how many of you were programmers? Or like, how many of you have been writing, how many of you have been writing, have been coding prior to now? If you have been coding prior to now, just say I do. Type I do. So let me know the number of persons that are joining the coding. Okay. Temi Ojo, Lancer, yes. Who else? Who else? Who else? Who else? Okay, yes. 3, 4. Awesome, awesome. All right. So this will help me to explain APIs. Now, you know, when you're building a normal Web 2 application where you have the front end separate from the back end, the way you interact with the back end is using APIs, application programmable interface or application programming interface, whichever one you want to call it. Now, these APIs is what the front end uses to interact with the back end logic and updates the database. Do you understand that? If you understand, say yes. Please keep the yes coming. Okay, okay, awesome. Now, just the same way you use front end to interact with API that updates the database or interacts with the back end logic, that is how the API works. API is for smart contract. Whenever you write a smart contract, it provides you an API. With that API and the contract address of the deployed smart contract, your front end can interact with the functions in that smart contract. That is just what API does. I don't need to read all this grammar that I wrote here. Just understand it. APIs gives you an interface for you to interact with deployed smart contract. If we go down to Remix now, if we go down to Remix, I click on this place here that's showing this guy. If I scroll down, can you see this API? This API now, if I copy it, let me create a new contract and paste it there. I'll call it API.so. Now, if I paste this here, look at this. This API gives you, so you see our contract has constructor. If you look this API, you see this constructor here. So our contract has a change owner function. If you look this API, you see the change owner function here. Our contract has a withdraw function. If you look this API, you see the withdraw function here. With this API now, if I create a React application and I deploy this smart contract, I can use that React application to interact with this smart contract on the blockchain. That is what API does. The same thing API does for Web 2. That's what API does for smart contract and blockchain development. So I won't deliberate much on that. That's already done. Now we have events. Events are just a way for you to log activities in Solidity. So for some of you that might have been writing back-end stuff before, maybe when a user signs up, you want to trigger an event on trigger of that event, it should send the user an email that, okay, your sign up was successful. So Solidity smart contract uses event the same way, but in Solidity, events are triggered to log activities on the blockchain, which the smart contract can, the front end can use to index or search certain actions on the blockchain. So that is basically what events is used to do and in smart contract development and all of that. And sometimes, if you want to do some high-level gas optimization, you can use events to store certain kind of stuff on the blockchain because it's cheaper to store things using events than to store things using state variables. So let's proceed. And the last stuff we have here is our factory contract. So a factory contract is a smart contract that enables you to deploy other smart contracts. It enables you to deploy an instance of other smart contracts. So this is supposed to be a topic of its own, but I just want to mention it. Now, you can have a smart contract. Let's say you have, can you guys still hear me? Sorry, this stuff has started again. Hello,
Yeah,
can
we can hear you.
all
We
right.
can hear you.
All right, can you see my screen?
Yes, bro, we can hear you.
All right. So
Yes, sir, we can see it.
all right, so
Yeah.
let's say you want to build a decentralized voting application, and you want it to be in such a way that users can come to that voting application and create their own voting pool. And you want to keep a particular voting pool to be independent of other voting pool. So you use things like factory smart contracts, whereby if a user wants to create their own voting pool, it will deploy a separate smart contract for them. And that separate smart contract will just anybody that interacts with that contract is interacting on a separate smart contract of its own, and it has nothing to do with every other smart contract. So factory contracts are used to deploy multiple instances of a particular smart contract. That's why it's called factory. A factory is a place where you produce things. You produce, if a car factory produce multiple cars and all of that. So a factory contract deploys multiple smart contracts of a particular instance. So when you get into practical, you understand this more. Now let's go, this is the sweetest part. Let's start building. Let's start building. I hope you guys have energy, because I do. If you have energy, type I do in the chat section. So let me know the people that are with me and the people that want to run. Do you have energy? We want to start coding. Awesome, awesome, awesome. All right, I'm heading back to this guy. So the first smart contract we are going to write, I'm going to start from the beginning. I'm going to delete this teaching stuff I created here. I'm going to delete it. What's happening here? Remix, what's wrong with you? Reload. Let's wait for Remix to come up, sorry. I have two people trying to join. Admit and admit. All right, Remix is back. Aha. So now I want to delete this teaching. I don't need it anymore. I've used it to do the explanations I wanted. All right, so the first pay attention closely, because I want to start everything from scratch, from how to create your file to writing your smart contract. And we are going to think through this together. So you learn how to write smart contracts. So this is basically proof of existence. So I want to create a setter and a getter smart contract, right? So the first thing I want to do is I want to create a contract. I'll click create new file. I like giving my contract the name of what it does. So once I see the name, I already know what the contract does. I'll call it setter getter.so, and I create this guy. Now, I'll just do my pragma here. It's going to give me everything I need, and I'll just say 0.8.4, one of my favorite compiler version. Now, I want to declare my contract keyword. I'll say contract, and I'll say setter getter, and I'll do this guy. This is my contract structure as far as I'm concerned, right? So now let's think. A setter getter contract, what does it do? All it does is it sets the value of a variable and also returns the value of the variable. So for it to set a value of a variable, remember, it will be setting the value of a state of the blockchain state. That means we need a state variable. So what I want to do now is, we need a state variable. What I want to do now is, what should we set? Let's say I want to create a contract that will be able to set my name, so I can change my name and I can also read my name. So I need a variable, a state variable that will be holding my name. And name is a string, right? So we are going to declare the type first string, and I call it name. Oh, what did I do? Sorry. Yeah, string, and I call it name, and I keep this guy. Now we have declared our state variable. What do we need next? We need a function that will be able to assign a value to this name variable. That is the setter function. So I'm going to call it function set name. And set name function is supposed to receive a parameter, which is the name. So set name function is supposed to receive a parameter or argument, which is the name we want to set. So I'm going to call it, and the type of the argument is string. Please, when you join, mute your mic. Sorry, Fido, can you mute your mic, please? All right. So the set name takes in, can you guys still hear me? Let me know if you can hear me. All right. So the set name takes in this argument. So I'm going to say string. I'm going to call it, I'm going to give it memory. Remember, it's a reference type. And whenever you're using a reference type, you always have to specify a memory location. So I'm giving it string memory, and I'm saying name. And I want this to be, this function will only be called externally. So I don't want to give it public, but I can give it public, it will still work, but I'm giving it external. And all this function does is, why is this thing throwing an error? All this function does is, it changes the value of name. So I'm going to set it equals to underscore name. Why is this throwing an error? I don't understand. Why? Set name. What's the error? Function.
Your second
Huh?
your second parenthesis for the contract.
Oh, okay. Yeah, thank you. Yep, all right, thanks. So this is it. So what the function does is, it receives the argument, and it sets this name variable to the new stuff here. And the next function is a getter function. What it just does is function get name, or we can call it show name. And this is a view function. Remember, we talked about view function. So external view, and it's going to return something. Returns, what is it returning? A string. And since it's a string, we have to make it memory. And we do something like this. Return, what is it returning? The name on the state level. This is what it's returning. And this is our setter. Solidity, I told you, Solidity is the most, as in, is the simplest programming language I've seen. JavaScript is not this simple. Or is it PHP? Or is it Rust? Rust will even kill you. But Solidity is so straightforward, like very sweet. Love of my life. All right. So we are done with our smart contract. So if I come here now, so this is where you see it's compiled. This is the compiler telling you that everything is good. This green check here means everything is good. It's all good. So if I click on this guy and I click deploy, I've deployed the contract. So this is the contract, setter getter. So now watch, guys, watch closely. If I click on show name, you see there's nothing here because this guy is empty, doesn't have any value. Now, let me assign the name to Lancer. If I call this Lancer, is Lancer still on this call? Okay, he is. If I call this Lancer and I set this name, it have set the name. That's why you're seeing this. Can you see this green guy here? So it's telling you that the transaction was successful. If I click back on show name, you now see Lancer here. If I change this to Mohammed, there's Mohammed on this call. If I change this to Mohammed and I set this, it has executed the transaction successfully. If I click show name, you see it's showing Mohammed. If I set this to who else? If I set this to Temi, if I set this to Temi and I set it and I clear this guy and I click show name, you see it's Temi. So that is the name of this contract, setter getter. Setter getter. You just set the name and gets back the name. Who are you guys following? If you're following, please type yes, because I'm increasing the level of complexity. The next contract we are going to write is more complex than this. Are you following? Is it making sense? Mohammed, Virtual, FX Media. Are you guys following? Awesome.
Yes, sir, we are following, sir.
All right. Now let's move to the next contract. The next contract we are going to write is a to-do smart contract. Now, you see that this first contract, we only made use of string as our variable, as a string data type, and we created these functions. Now we want to move a little bit higher to a different level. Now this new level, advancement, we call it advancement in knowledge. So let's move over to a new level. I want to create another contract. I'm going to call it, I'll call it to do. So I'll call it to do dot so. Awesome. Now, same thing, we'll do our pragma. It gives us this guy. Now I want to use a different Solidity compiler version. I'm going to use at 0.8.14. Yeah, this works. So I'm going to declare the contract keyword, and I'm going to say to do. And here we are. Our contract structure is ready. Now let's think. Let's think, guys. Let's think together. I want you guys to unmute your mic. Let's think together. What makes up a to-do? Unmute your mic. What makes up a to-do? Like if you want to create a to-do application, one of your to-do should have a couple of components. What makes it up? Hello, guys. Please chat with me, please. Unmute your mic, say something so we build this together. Hello, what makes up a to-do? Okay, let me just go ahead since no one is saying anything. A to-do.
You have a checkbox.
You should have what?
A checkbox that you can, like, how will I explain it now?
Okay, I'm talking about the components of a to-do. You know, when you want to create a to-do, you need a place that you put the title of your task. Let's say you want to,
Yes, the calendar.
You're talking about the front end. I'm talking about components like a to-do title. For instance, I want to pray by 7 o'clock. So first of all, the title is pray.
Title, yes.
The second thing is the description. The description can be, okay, wake up and pray by 10 o'clock. Then another thing is status. If you've done that to do
To
or
do.
not done. So now,
What is
hello?
a to do?
Oh wow. Okay. A to-do application is
Oh
an
wow.
application that enables you to keep track of the list of things you want to do, like your
Like a
in a day,
reminder or an
like
alarm
a
or something.
reminder. So you use it to keep track of the things you want to do. And anyone you've done, you check it that, okay, I've done this one, you move to the next one. Does that make sense?
Okay, sir.
All right. So now every to-do application has their components. Please, you can mute your mic. Every to-do application have a list of components. Those components are what makes up a particular to-do. And this is where struct usage comes in very handy, because struct enables you to group data together. So now I want to create a struct. So I'm going to call it struct. I can call it to-do items. To-do item. So what makes up a to-do item? As someone said there, title. Title is of what type? String. So the first thing is to put in the string and say title. And you kill this guy. When I mean kill, like end your statement. Then the second thing we have is the description of the to-do, and it's also a type of string, and you call it description. You end your stuff. Now, the last stuff we have, I don't want to call it status. I want to call it something more descriptive. So I'll call it is, sorry, this would be a bool. I'll call it is completed. Now you can make this to-do stuff to have like complex this thing. I can add something like timestamp to it, but I don't want to get you guys confused. So let's keep it simple. Now this is our to-do stuff. And now the next thing we want to do is we need a way to store all our to-dos. And how do we store all our to-dos? This is where an array comes in handy. We put all our to-dos inside an array so that we can always return the array. So now, remember I told you that an array holds elements of a particular type, and we want our array to hold these to-do items. So what we are going to do is we are first going to declare the type here. Remember, to-do item is a type, and we put this array. And what we are going to call this is to-dos, because this holds all our to-dos. All right, let's move to the next guy. The next function we need is the function to add our to-do. The function to add to-do. So we write our function, call it add to-do. This is going to be an external function like this. And this function is going to take in this title and this description. This one, it will not take it now because this one, the default will be false. So first thing first, we're going to say string memory, and we say title. And the second one is string memory, and we call it description. Right? We have gotten our function structure. Let's move over to the next guy. The next function is the function that will display all our to-do for us. So we'll call this one show to-dos. And inside here, we don't need to pass in anything. All we just need to do is say external view function return. So this is going to return an array. An array of what is it returning? An array of to-do item. So we are going to say this guy is going to return an array. An array is a reference type. Remember, reference type, you need to put in a memory location. And we keep this guy like this. Now, what else do we need this to-do function to do? We need our to-do function to be able to, we need to be able to like change its completed status of our to-do. So we'll call this function update to-do status. There's a reason why I named this stuff like this. And what will it take? This is supposed to take the array index of the to-do. So we are going to call this uint 256. Normally, uint 256 is too big for something like this, but to keep it simple, let me not confuse you. We'll call this, let me call it to-do, you can call it to-do ID, or you can call it to-do index. So to-do index is more descriptive because it tells anybody that is seeing this that it is an array index. So this is an external function. And we do this guy. Now, what else do we need? What else do we need? We can add, we can show, we can update. This is basically in Web 2, they call it CRUD operation, create, update, create, read, update, delete. So let's create a delete so that we will be able to delete to do. Delete to do. So this is also an external function. I'll keep it like this. I've going to remove this stuff again. Yeah, we'll keep it simple. Now we have gotten the complete structure of our smart contract. Now let's fill it in. First things first. We need first things first. We need to first initialize our struct. But I can do it in a way that we don't need to initialize. There are different ways to initialize the struct. I'm even thinking of the simplest one to use. Okay, so first things first, we can do something like, for this guy, we can do something like to-dos. Remember, this is an array, and there are stuff we call array methods. In PHP, in JavaScript, in other programming language, push is one of the array methods to push things into an array. So we say dot push. Now, what are we pushing? We are pushing this to-do item, which is this struct here. And inside this guy, I want to do something like this. I want to do this guy, and I'll say the title of this guy, I'll set it to this title we are receiving here. I'll put a comma. The description of this guy, I'll set it to the description we are receiving here. Pay attention to this syntax. Now, bool, this is complete. We need to add it because if you're using this pattern of initializing struct, you have to fill in all the struct members. All these things inside this struct, they are referred to as struct members. So take note of the jargons, the Solidity jargons, struct members. So they default this to be false. And with this, we end this guy. Why am I getting an error? Oh, sorry, to-dos. I'm missing an S. To-dos, yeah. All right. So we have created our to-do. Now, let me show you another pattern to do this. Another sweet pattern to do this. If you don't want to use this pattern of initialization, you can use this other pattern. You can say something like to-do item, storage, to do item storage. I call it new to do, right? I set it like this. Now I'll now say new to do dot title is equal to underscore title. You kill it. Why is this guy throwing me an error? Storage pointer type. Let me change this to memory and see. All right, awesome. Now, I'll now say new to do dot description is equal to underscore description. I end it here. Now, I don't need to set this one because this one by default is false. All I just need to do then is just say this array, which is to do dot push new to do. And we are good. Now, can you see this is another pattern of initializing a struct? This is one pattern. This is another pattern. So which one do you prefer, guys? First or second? If you prefer first, type first. If you prefer second, type second. Answer said first. Okay, first. Okay, let's go with first then. Mohammed, which one do you prefer? Is Mohammed still on this call? Okay, Mohammed is still there. All right. So let's use the first one then and remove the second one. All right. So this is our adding of to do. Now, we want to show all the to-dos. We want to show all the to-dos. All we just need to do is return the array.
Yes, sir.
Yeah?
So please, like some of those things I have not learned to this level. Is there any other class for beginners like me?
Don't worry, don't worry. We are going to provide you with resources. And did you sign up on Lumos Academy yesterday? Because there's a whole lot of articles on Lumos Academy that will help you to write wonderful smart contracts.
I did not sign up yesterday. My phone was down.
All right. So after this call, you can sign up. Then you can take the courses on the Lumos Academy. They are well detailed with code snippets and examples. All right, so let's proceed.
So is it?
Pardon?
Okay, then.
All right. So this show to-dos just returns the to-dos array.
Can you hear me?
Yeah, I can hear you.
I said.
You're breaking. So let's just wait. After the class, you can ask me all your questions. I'll answer.
Okay.
We don't delay. All right. So this show to-dos just return all the to-dos, which is the to-do array. And there's one function we were missing, a function to return individual to-do, like to return a single to-do. Let's say function, this will be show to-do. So this one will take the, it's going to take uint 256, and it's going to take to-do index, and it's going to be an external function that returns, this is not returning an array, it's just returning a to-do item. And this is memory. And this is just going to return one to-do. Okay, so we have completed the second function. Let's do this other function. This one now, we want this function to return an individual to-do. So all this does is it returns the to-dos with a given index, with a to-do index. So this will return an individual to-do. Sorry, it's supposed to be a view function. That's why this guy is complaining. External view, yeah, returns this guy. So the next guy we want to set is to update the to-do status. So there are different ways to do this. Different ways. So Simple. What you just need to do here is you get the to-dos array, right? With the to-dos array, you get the to-do index. With this to-do index, you've gotten the particular to-do you want to update. Now, remember that this to-do returns this struct, so you can access what you want to update. So what I want to update is the dot is completed. Is completed. Oh, I'm over typing fast. The dot is completed. What is this? Completed. Is completed member. And I can set it to true. But this is not what I want to do. I want users to be able to toggle. You can toggle it true or false. So what I want to do here is I will do, watch what I want to do. I'm going to do this. I'm going to say not this guy. Now, what this does is, remember that if I want to update this status when it is false, the negative of false is true, so it will set it to true. And if it's already true, the negative of true is false, so it will set it to false. That is what this line is doing. Isn't Solidity awesome? Are you guys not enjoying Solidity? So the last function here, I don't think will be, I don't know. Sarah and Tosin, will you guys permit me? Should we still write ERC20 contract? Because the time is almost getting to 9 and we're supposed to stop by 8. Can you guys hear me?
After ERC20, do we have any other one?
Look at the so we should just stop at ERC20. There's no need building a staking contract.
ERC20 is quite short now, so think it can.
All right, great. Okay, so let's continue. Now, delete to do. How do we delete a to do? So to delete a to do, there's a keyword called delete in Solidity. So let's see. Delete. This guy. We just want to delete this guy. Oh, we didn't pass the index of the guy we want to delete. So we need to take it in. We need to say uint 256, and we call this underscore to do index. So this will delete the to do from the array. And mind you, it just deletes that position in the array still exists, but the value will no longer be there. So with this, we are done with our to-do smart contract. Now let's test. Let's deploy and test. So note, the deployment we are deploying is inside the Remix environment. If you want to deploy on the blockchain, you need to connect your wallet. So for instance, if I want to deploy on the blockchain now, all I just need to do is click Injected MetaMask, and it's going to connect with my MetaMask wallet. And once it connects with my MetaMask wallet, if I deploy, it's going to deploy on the blockchain that I've selected here. And this is the Sepolia blockchain. I can deploy on Mumbai. I can deploy on Ethereum mainnet. I can deploy on many other blockchain and all of that. But for now, let's keep using Remix. So now let's deploy our blockchain, our smart contract. The final step of every smart contract is to test it. You are never sure of your contract unless you've properly tested it. Okay? Okay. So let's continue. Let's delete this guy. And we want to deploy our to-do contract. Click on the to-do. We have deployed it. Now let's interact with it. First of all, let me click show to-dos. You see, this is an empty array. Can you guys see my screen, please? This is an empty array. There's nothing here. So now I want to add a to-do. The title is Eat Dinner. I love food. The description, I want to eat by 9 p.m. and I transact. With this green check, it shows that this transaction is successful. Now, if I click show to-dos again, you can see this guy, eat dinner, comma, I missed something. I want to eat by 8 p.m. And the status is false, as you can see. Now, let me add another to-do. Go to bed, sleep by 10 p.m. and I transact this guy. If I go down here and I click show to do again, you see we have our go to bed, sleep by 10 p.m. and false, right? Okay. Now, let's now show a single to do. Now, based on the way array is, the first element is of index 0 and the second one is of index 1. So let's show a single to do. I'll pass 1 here and I'll click this. You see, it's returning the second element, go to bed, sleep by 10 p.m. If I pass 0 here and I click this, it's returning the first element in the array, right? Now, pay attention. If you see this second guy, this status is false. Now I want to update the status. I want to put 0 here and I click update status. Now, if I click show again, you see that the status is now true. If I click update status again and I click show here, the status is false. Now let me update the second element. If I click update and I pass this guy here, you see the status is true. Now let's delete the second element in the to-do. I'm passing 1 and I'm clicking delete. It has deleted. If we show this guy again, you see that the second element is no longer there. It is only the first one that is there, which is the eat dinner. I want to eat by this thing. So this is our to-do smart contract. Hello guys, does it make sense? A lot of persons have dropped from the call. It's like, it's getting choked up. Does it make sense, guys? Those of us that are still here. Awesome. Awesome. All right. So the last contract we are going to be building today, which is the highlight of everything we have been doing, is the ERC20 smart contract. So the ERC20 smart contract, I won't go into details of explaining each of the functions in the smart contract, because there's a library called OpenZeppelin that has already made it easier for you to create tokens. All these tokens you see on CoinMarketCap, on Binance that people trade, I want to show you how you create them. As it's the simplest thing. In fact, if building things on the blockchain is like letter A to Z, creating a token is like letter A, is the A of the whole thing. Very simple. So how do we do that? I'm just going to show you guys one ERC20 contract that I created. So this is it. So look at this contract. All it does, it imports this library from OpenZeppelin. This library has all the function that makes up a token. Because of time, I won't be explaining each of the function one after the other. Now, this is the name of the contract. I called it stablecoin. And I'm inheriting this ERC20 from OpenZeppelin. I already showed you guys how to inherit. And in this inheritance, I'm giving this token a name. Now, watch, guys. I want to call this token Lancer token. So I call it Lancer coin. and the token symbol is LSC, Lancer. Now, I want this token to have an owner. It is only the owner of this token that can mint this token to any other person. And who is the owner? The owner is the person that is deploying this smart contract. Once you deploy this smart contract, it sets the MSG.sender. MSG.sender means the person interacting with that contract at that point in time. And the person interacting with this contract at that point in time is the person deploying it. So the MSG.sender is the owner of the smart contract. Now, inside the constructor function, I am telling it to mint this amount of token to the owner of this smart contract. So once I deploy this thing, it's going to mint this amount of token to my address. Now, I now created another function called mint function. It's an external function, but only the owner of this contract can call it. See why I put a require statement. Require that the person calling this function is the owner. Else, revert with a message that you are not owner. And if this line passes, it will now mint more tokens to the MSG.sender. So this is where I'm passing the amount of token I want to mint, and it will mint more to the MSG.sender. Now, this contract, we are going to deploy it on a live network, on a live test net. And if I deploy it, I will show it to you. Now, for us to deploy this contract, I want us to deploy this contract on, this is the stable coin. So it's compiled. Let me delete this to do contract. I want us to deploy this contract on Polygon. Oh, I don't have Sepolia test ETH, but I think what I have to do. So I'm going to the deploy section and I'll select injected provider. You see my MetaMask is popped up. I'll select MetaMask and my MetaMask is connected. Now, to deploy this contract, if I click the deploy, watch, MetaMask will pop up for me to sign this transaction. And I'm going to sign it. Watch, guys. And wait for the transaction to confirm. This is live blockchain deployment. This one is no longer a Remix environment. Now, this has been deployed. Let me click view on Etherscan. I'll send this stuff to you guys. Now, look at the token. This is the token on the blockchain. I'll drop this link now in the in-call chat. You can check it out by yourself. This is the token. So let me see if this token has been deployed. If it minted the token for me, I'll now go to my MetaMask. I'll go to tokens. I'll import token and I'll paste the token address. Now, can you see LSC here? Can you guys see LSC? If you can see it, type yes, please. Yeah. So if I click next and I click import, can you see it minted this amount of 100,000 LSC to me? I can send this token to anybody. Lancer and Mohammed, can you drop your wallet address in the in-call chat if you have MetaMask? I will send this token to you and you will receive it in your wallet. Now, I can add this token on any exchange and drop your MetaMask wallet, any MetaMask wallet. I can add this token in an exchange and you will see it live and direct, and it will be, you can buy it. People will be trading it, but that's if I deploy on Binance, or if I deploy on a live mainnet. So if I copy this address you dropped, I click on send, I'll paste it here, and I want to give you 1,000 pieces of this token, and I click next, and I click confirm. Now wait for this transaction. Once this sends, use this, let me give you once this sends, I'll send you the token decimal. So the token contract address, you can add it in your MetaMask and you see everything is working well. Sepolia, okay, it has sent. So let me go back here. and give you the token address. So this is the token address here. You can use it to add this token in your MetaMask. I can drop it in the group as well. So you can, because if this call ends, you might not get it again. So this is the token address in the group. So you can add it in your MetaMask and you see that 1,000 token I sent to you. Okay, let me send it to this guy too. So let me send, I'm running out of gas fee. So let me send, oh, sorry, this is not what I want to say, sorry. Cancel. I want to send the token. Yeah, LSC, send. I'm pasting your wallet address here. And I want to send 1,002 to you. Send. And do this. So why this is sending, I want to show you guys something just so that you understand what I'm talking. Popular tokens, see how they are created. I'm taking you to CoinMarketCap just to show you something. Watch, guys, pay attention so you learn something. Now, I want to look for a popular token called ChainGPT. So, ChainGPT. Now, this is a very popular token. Now, look at this token. People are trading it. It's on PancakeSwap, it's on KuCoin and all of that. Now, let's go to their GitHub. Can you see this? Let me maximize. So this is their GitHub. Let's go to their GitHub and check something. Can you see their GitHub? If you can see, type yes, please. Can you see their GitHub? All right, I'll click on their GitHub so that you see the token. Now, this token, this ChainGPT, this is the ChainGPT token. Let me click on it. Watch, guys. Now, this is the smart contract, ChainGPT.sol. I'll click on it. All right. Can you guys see the code that makes up the token that everybody is buying? Can you see the code? It's just importing this guy, OpenZeppelin ERC20. This is the token. This is where they declare the name of the token, and it's minting this amount to the MSG.sender. This bondable they added here means users can bond this token. This ownable they added here is doing the same thing as this owner you're seeing here on line 7. That's what this ownable you're seeing here is doing. This ownable here now, this ownable that they imported, that they are inheriting here, is doing the same thing as this address public owner here. Very simple. And everybody is buying the token. So with what you've learned today, you can create your own token from the comfort of your home with just nothing more than 10 lines of code. And I believe with this, we have come to the end of today's workshop. Now, let's go to the next slide. I have a couple of assignments for you. Study the following bullet points. What is a dApp? Introduction to Web3, Web3.js and Ethers.js library, JavaScript library, connecting Ethers.js to a deployed smart contract, building a dApp with React.js and Solidity. All these are the things I need you guys to study on. If you're able to finish this, I'm sure you write more smart contracts and you get to know a lot of things and about the blockchain and building decentralized application. And finally, the end, shares and keep building. So you can sign up on Lumos Academy. I'll share this link, and you can follow Lumos Academy on Twitter at Lumos Labs HQ, and also on LinkedIn, Lumos Labs. So we are here now. Ask your questions, and you can check the Lumos blog for some awesome content and to get in touch or keep in touch with Lumos. So ask your questions. The floor is open. Those of you that were able to make it to the last minutes, kudos to you. You are the real MVPs. So ask your questions. Hello, can you guys hear me?
Lancer, you said you were having one error now.
Oh, okay.
I don't know. Lancer complained of error at some point. He was still on
Yeah.
the call.
Tosin, have you been able
Can
to?
can you hear me?
Yeah, I can hear you.
Okay, I was having the error when I was trying to, because I was trying to like follow along as you were building the to do, but I ended up rectifying it. The when you are like you said something that what's the name? Solidity is it static or is strict, whereby we have to like manually define the data type when we're
Yeah,
implementing.
yeah.
And I noticed it when we're using the uint. The uint is we're declaring the value type. That's the numbers. Well, I noticed there was one place, I think was it in the stable coin code, or probably they declared the string, and I did not see exactly ARC20. I didn't see the string keyword there, but that's a string. I don't know
Okay.
if there's a different.
Okay. Yeah. So now do you know the difference between parameter and argument?
A parameter is, as you are calling the function, you are passing in what the function is going to use to like in its code as it's running. Then argument is after you have already called the function, you are passing in the parameter as actual values.
Yeah, very correct. Now, at this point, we are passing in the actual value. We are not declaring the parameter. We are passing the actual value. So if you check, let me show you something. If you check this contract we inherited, this ERC20 contract we inherited, let me copy it and show you something. Let me open it in my browser. Yep. Now, that is a constructor. Can you see this?
Yes, I can see it.
You see, we are taking in the name and the symbol, and we are
Yes.
setting it here. That is, here now is where they will declare the constructor. This is where we make use of the parameters. But in this other place here now, we are passing in the arguments. We are passing in the actual value. So we don't need to put memory and all of that again. Does it make sense?
Yes, sir. Thank you, sir.
Yeah. Any other question? Shoot your question.
This second one is more of like a personal question.
Yeah.
So like the token, when I tried copying it, because when you did yours, it's actually auto-populated, right? I saw the LSC and the decimal, but upon using it in my own MetaMask, it didn't actually auto-populate. I had to like manually do that, and after doing that, it still did not like
show the
I didn't see the tokens.
Okay, check which network are you in your MetaMask, because we deployed this smart contract on Sepolia blockchain. So if you are in another network, it will not work. See, I'm in Sepolia.
Okay.
If you are in Goerli, it will not work. So you have to be in Sepolia. That is only where it will see it. Does that make sense?
Okay. Yes, sir. I've seen it.
All right.
Okay, and can I ask another question? Sorry, sir.
Yeah, go ahead.
Okay, so I think throughout the course of yesterday and today, this stuff has actually been confusing regarding the wallet's address stuff on MetaMask. Like now, when you wanted me to copy you said any wallets, and I copied a wallet on Polygon.
Any address, any MetaMask.
Yes, any MetaMask address. Yeah. But the address I copied was from the Polygon Mumbai mainnet.
Yeah.
So I want to the question I want to ask is how do they work? Like I copied the stuff on the Polygon Mumbai, right?
Yeah.
But the stuff still actually entered. But entering is under the Sepolia, the way the stuff works behind the scene. I don't know,
all right. So
the stuff is just actually confusing.
Now, MetaMask is an EVM compatible wallet, which means it will work for every EVM compatible blockchains. Remember when I was listing the EVM compatible blockchain, I told you that Solidity is a smart contract that works on all EVM compatible blockchain, which is Ethereum, Polygon, Binance, Arbitrum, Avalanche, Phantom, Optimism. You can name them. There's Nami, there's Celo, there's Mantle. You know, all these are EVM compatible blockchain, which means with one code, you can deploy on any of these blockchain. So Ethereum, MetaMask is a wallet that works on all EVM compatible blockchain. The only thing you need to do, one address can work on all those chains. The only thing you need to do is just change the network. And every network has what they call RPC. It is the RPC that connects that wallet to a particular blockchain. For instance, if I click on this wallet now, and I click on, let's go to, where is it? Settings. Now, if I go to networks, you can see, you see Arbitrum, you see MXC, you see NAMI, you see Goelia, all of these. If I add a new network now that is EVM compatible, it will add it to this chain, to this MetaMask wallet. It's one address, but it can work across all EVM compatible blockchains. That is why when you send that address, as far as it is an Ethereum address, if I'm sending from Binance, all you just need to do is switch your blockchain to Binance or MetaMask, you see the money. Does it make sense?
Yes, sir. I understand better now. Thank you, sir.
Awesome. You're welcome. Who else? I need questions. This is the best time to ask me questions. Okay. No more questions. Okay. Tosin, over to you. You can take over from here. I think at this juncture, I am done. Are we good?
You really fired me. Like, but you did not send me my own answer to me.
I sent it now. I sent it. Check it out. I sent it. Just import it in your wallet. You see it. This is it now. This is the first person. This is the second person. You are the second person I sent it to.
I did not see you copy my address. I thought you did it like that.
I copy. No, okay. I am all the chat section and the participants are in a different screen. Only the screen I'm presenting is what you're seeing.
Man, I think we even need to reward Lancer. Quite, I don't know, it was quite consistent and stable.
That was why I created a token in his name.
So, Lancer,
Yes, sir.
I think
Yes,
other people
Temi
also-
Ojo. So Temi Ojo is still here. Mohammed is still here. So kudos to you guys that made it to the final rounds. So we can go through the video. You can create tokens in your own name too and request for my address. I'll send it to you guys to send me some money. All right, please go ahead to see.
Yeah. So basically, definitely I understand, and it's quite obvious that we all enjoyed the session. So would you guys be interested in like something like this? Not necessarily like ERC20, but we can like do subsequent sessions on like other building other decentralized applications as well. Do you think how frequently do you think that okay you guys want something like this as well? Down for weekly or maybe monthly or as the case may be.
So personally, I would like to go first. Sorry. This is actually very, how would I put it? Something like this is actually great because learning something like this on your own, the way Mr. Kasuni has actually put us through a lot of stuff, it has actually like closed down the gap in that learning curve, the amount of time to take us to actually understand some particular concepts. He's actually writing out the codes and actually explaining the concepts as he's writing that. So I feel like that creates an avenue whereby assimilation becomes very fast. And when it comes down to how frequent they are, well, personally, I feel like this Friday, Saturday stuff is not actually bad. And if you want to have more sessions, I feel like majority of us would, or personally, I will be down for it. That's just my own opinion.
Yeah, okay. But I don't know how technical a lot of the audience are. a big fan of. I would have suggested we just like stick to just strictly coding, like technical sessions every weekend. For a lot of the people, I remember somebody was also complaining about maybe this being a
Yeah.
bit um,
So
Mohammed.
okay. So for me, also like Lancer said, uh, this section has really helped a lot. Though I wasn't able to join yesterday section because it clashes with another meeting that I had. But I really like having session like this because I've been writing code before. I tried doing Web3 sometime, but it's a little bit difficult compared to how it was taught in this section. So that's what I have to say.
So you would love something like this. I don't know. I didn't hear you for some
Yeah,
time.
yeah, exactly. Yes.
How frequently are you down?
Sorry, is that what?
Like how frequently are you down? Like maybe weekly, monthly, I don't know.
Yeah, I think weekly, like weekends basically for me is fine. Weekdays, if towards evening, like 6 to 9. So, but
Works fine.
during, weekdays, I might not be available from around like 9 to 5. So
So
sometimes I might be
would that
available, but I'm not certain. Yeah.
right? All right, that makes sense. That makes sense. So we can work with weekends. We can work with weekends. So for all Temi, can you speak up? I don't know, you've been quiet. Temi,
Good evening. Can you hear me?
so yeah, I can hear you.
Can you hear me? Yeah, I
Yeah.
feel the weekends will be the best. Probably like Friday to Sundays. Probably work well.
Okay. So
Even during the evening, like from 5 to 6 or five to
yeah,
six, can start around 5 or 6.
would you be interested in like maybe more advanced concepts like G-Spoons or maybe beginners, much more beginner friendly as
Mm,
well?
I think I is it possible for us to do both?
Were you able
Because
to follow along with today's session?
yeah, I was able to follow along. I understood almost everything today.
Yeah,
I'm not new to programming. I've programmed before, so
exactly.
it helped me.
So I don't think we need to bother about the beginner aspect of that much because I think
Okay, yeah, yeah.
Kasumi is quite a good teacher. So you should with your
Okay.
basic background in yeah, you should follow along very
Yes, yes, yes. That makes
well. All
sense.
right. So that makes sense. So for our individual sessions, if you would like want to go self-paced, you can also check out the Lumos Academy link. I actually sent it to the group. I will send it this evening. Right. So you can also check it out. There's also a course on getting started with Web3, um, like Ethereum as a Web2 developer, right? So aside the intro to Web3 course, there's some other course that actually like deals with something similar to what we actually um, dealt with today. So maybe during the week, whenever you find some time, you can also go through it by yourself. Uh, there's also I would also attach the link to the Discord channel, right? So if you're very familiar with Discord and you need a community that is always there for you, right? You can also like open as well and ask your questions. So we look forward to having you guys. And I'm quite sure you guys enjoyed the session. So I think that would be all. That would be all. So we can actually like we can type in the WhatsApp group to show to tell others how much we enjoyed the session. So as to encourage people to like join for other times as well.
Also, we noticed, when it started getting a lot more technical, a lot of persons dropped. So I think one of the very good criteria for learning blockchain development is you're already a developer, like you're already be writing some kinds of codes, like little of solid, even if it's Solidity or PHP or even if it's JavaScript, PHP or React, like just have some level of program. Because once we start getting into smart contract development, everything start turning on its own, and people start their head will start
Oh.
here. All of that.
There's knowledge gap like in the audience. We can't actually like live out with maybe have like a little technical experience. So I don't know. How do we go about that one? In
Well,
as much as okay, there's a gap now. There are some people that are not very technical also in the
yeah.
audience.
So that is why one of the things Lumos Academy is doing, what we do at Lumos Lab, and it's moving Web 2 developers to Web 3. You get it? That means you are already developing in Web 2 before you want to transition to Web 3. Not just waking up and moving straight to Web 3. It's just like moving from nursery 1 to university. It's like you're skipping all the nursery 2 transition, primary 1 and the rest. You're just moving to university. Yeah, you can actually do that. You can actually do that, depend on your level of commitment and consistency. But you need to first understand how programming works somehow, like a little bit of JavaScript basics, like you just know these things. Then when you come to Solidity, everything will start making sense. But jumping straight, no Web 2 knowledge, nothing, like your first introduction to programming, you just hit Web 3, Solidity. By the time you start hearing deploying smart contracts, mapping, all this kind of stuff, your head will start getting hot. And a lot of times, if you're not strong, you might not be able to keep up. Yeah. Can you hear me?
Yeah, I get. Yeah. I agree with what you're saying. Okay, so I think that's all basically. We've exhausted a lot of time. That's like 3 hours. That's 3 hours. So guys, it was nice hanging out with you guys. So Kashmini, thank you very much for the session. It was quite knowledgeable and enjoyable. Hope like having you guys maybe next week or some other time. Can you hear me?
All right. Bye, everyone. Thanks for staying around to the end. Don't stop here. Keep building and have a wonderful weekend. Bye. I'll be ending the call now.